In this video, we're going to talk about approximations. Now, some people, possibly even including me, they don't like it. I'm talking about instructors. They don't like this section because these days they have calculators that make it so that you don't need to approximate anything. Just type in a few buttons on a calculator and you find the exact answer. Now, I like this section, I guess, for the, what's it called? For the theoretical idea behind it. But in terms of using it in practice, there's really no need for this anymore. But let's do it. We know that f prime of a, by definition, is the limit as h goes to 0 of f of a plus h minus f of a all over h. Now, if we drop the limit part of this, we have that f of a is approximately f of a plus h minus f of a over h, but this is only for h small. If h is really big, it's not a good approximation. Now, treating that symbol in the middle approximation like our equal sign, let us solve this equation for this. That is h times f prime of a is approximately f of a plus h minus f of a, and bringing this term to the left side, we get f of a plus h times f prime of a is approximately f of a plus h. Now, I just want to write the main thing first. I want to write this first. That is, f of a plus h is approximately f of a plus h times f of a. And this here is our approximation formula. And I do not walk around knowing this formula, but I can easily get it from this limit or from without having the limit. Again, all I do is solve for that algebraically. So now, one more time, this is only a good approximation if h is small. The bigger h is, the less meaningful the approximation has. So suppose we want to know the square root of 17. Now, the game is you want to pick an a closest to 17 that you know the square root of. So I'm going to let a be 16 because I know the square root is 16. And I'm going to let h be 1. And just for the record, a plus h is 17. Exactly that number. And then I'm going to define, well, what do I want done to 17? Let me do the same thing to x. Well, what I want to do to 17 is take the square root of it. Oh, I'll take the square root of x. Okay. Now we have everything we want. F of a plus h is equal to, well, f is, no matter what goes in there, you take the square root of it. So this is the square root of 17. Well, that's good. So the left side is what I want. Now, I want to calculate it by doing the right-hand side. So f of a plus h times f prime of a. Well, this is equal to the square root of 16 plus 1 times f prime of 16, which is 4, plus multiplying by 1 doesn't do anything, plus 1 prime plus f prime is 16. Well, before I can find f prime of 16, I need to know f prime of x. Well, f of x is the square root of x, which is x to the half. I only write it that way because it's easier for me to take the derivative in that form. So f prime of x, well, you bring down the half, you make the new power 1 less. So this is 1/2, and I'll put this in the denominator because it's a negative exponent, and now it's positive. That is this 1 over 2 square root of x. So now I can try to find f prime is 16. F prime is 16 is 1 over 2 square root of 16, which is 1 over 2 times 4, which is 1 over 8, plus 1 over 8. So I am approximating the square root of 17 as 4 plus 1/8. Now, 1/8 happens to be 0.125 exactly. So I am getting 4 plus that. So I get 4.125. So let's write that down. The square root of 17 we calculated as 4.125 using calculus. And a calculator would instantly tell me that it's close to this number. But of course it goes on forever. Well, you know, I had the 4.12. I was off on the third digit. Pretty decent approximation. Pretty decent approximation. If h would have been smaller, we would have had a better approximation. Now, let us approximate 4.9 squared. Now, even without a calculator, it's probably easier to just multiply it out by itself. Get 81, 36, 44. Indent one space, 36, 19, 1, 0, 4, 2. So it is exactly 24.01, and I got it without a calculator pretty easily. But we want to use calculus. F of a plus h is approximately f of a plus h times f prime of a. Well, a is the closest number to 4.9 that I know how to square, and that's 5. And when I add h, I should get 4.9. So h is going to be negative 0.1. And then a plus h will be 4.9. Okay. Now, what am I doing to a plus h? What am I doing to 4.9? I'm going to do the same to x. Well, it's pretty clear. I'm squaring it. So I'm going to square x. Okay. And the derivative of that is 2x. So now I want f of a. A is 5. Oh, you mean you want me to square 5? Okay. So I get 25. 25 plus h is negative 0.1 times f prime of a. Well, f prime of 5 is 2 times 5 is 10. So I get 25 minus 0.1, which is 24.9. Of course that's wrong. If I multiply this number by 1, I'll get back itself. Excuse me. 10 times 0.1 is 1. So I claim the answer is 24, which is 24.00, which is really close to the exact answer. That was a pretty good approximation. Okay. Let us do another one. Suppose we want to figure out what 7.9 to the 2/3 is. What is this approximately equal to? Okay. Well, I know what 8 to the 2/3 is because this is asking what times itself 3 times gives me 8, and that answer is 2. 2 times 2 times 2, yep, that's 8. And then I have to square my answer. So yeah, I do know what 8 to the 2/3 is. So I'm going to let A be 8 and H be such that A plus H is equal to 7.9. Again, 8 is going to be negative 0.1. Okay, now what am I doing to the 7.9? That's what defines what x is. Oh, I'm raising it to the 2/3. So I'm going to take x and raise it to the 2/3. That means f prime of x will be, bring down the power, make the new power 1 less. So it's 2 over 3 x to the 3rd. Now, I know what f of a is. That is f of 8 is 8 to the 2/3, which is 4. Now, what is f prime of 8? Well, it's 2 over 3, 8 to the 3rd. 8 to the 3rd is 2. So we get 1/3 because those 2's cancel. Okay, and now we know that f of h plus h is approximately f of a plus h times f prime of a, and a plus h is 7.9, and our function raises to the 2/3, and this is approximately f of a, which is 4, plus negative 0.1 times f prime of a. F prime of a is 1/3. Well, 1/3 is 0.333 forever. And with the, excuse me, 0.1 is the same as 1/10. So 1/10 times 0.3 forever. Well, this is 0.33 forever over 10. Well, if I move this decimal 1 place to the left and this decimal 1 place to the left, I'll have 0.03 forever over 1. The rule for dividing by 1 is don't bother. So what we have is 4 minus 0.03 forever. And this gives me 3.96 forever. 3.96 forever. Okay. Now, one last thing, and we will be done with this section. Via a calculator, this answer also gave me an approximation, and it gave me 3.966596 833 583. Well, I had it up to 3 decimal points, and if I rounded to the 4th one, since that's a 5 and that's over a 5, this would round to a 6. So, I got an amazingly close answer. Got an amazingly close answer, and that's because h was fairly small. So, this is just fun to play with. Of course, if you want to know what 7.9 to the 2/3 is, you just use a calculator, or you go online and use some software. Okay. It would probably take less time to go and turn on your computer and find some kind of a calculator than to do all this work. And as always, we don't know if we made a mistake or not, or will make a mistake. But the bottom line is that I've done the following. If I wanted to know, for example, what 7.9 to the 2/3 were, and I wasn't in front of a computer, I didn't have a calculator, well, I did just what I just did now. So maybe it does have its value. Okay, that completes this section on approximations.